Nobody was with us in chemistry last month. Okay, well, we talked about the mole last month, and so we're going to look at a review of that real quickly before we move on to our stoichiometry. So just reviewing what the mole is, you might already have a notion in your mind, but a mole overall, it's just simply a word that represents an amount when we're talking about the mole in chemistry. And in terms of that amount, it can be related to several different things. So we're not going to relate it to just one particular thing. We can actually relate it to several different things, and we're going to talk through what we can relate that mole to. So the mole can be related to three different things. We said it can be related to mass, and when we're talking about mass, we're going to use the actual unit of grams. And what we'll do is we'll just simply use the periodic table, and we'll use the mass from the periodic table. And that's the mass in 1 mole of a substance. And that's called the molar mass. We can also relate the mole to the number of particles, and different things that are examples of particles would be atoms, molecules, and formula units. Molecules if we're talking about molecular compounds or things that are covalently bonded. Formula units if we're talking about ionic compounds or things with ionic bonds. And our particles is going to be a set number. It's Avogadro's number. There are 6.02 times 10 to the 23rd particles in 1 mole of a substance. And then we can also relate to volume in liters. This is only for gases at STP. This is one of the most common mistakes that students will make. They'll try to use this conversion with solutions as well. When we start to talk about molarity, they think about moles per liter, and they'll try to throw this conversion factor in there. But this is for gases at STP, which is standard temperature and pressure. And we have a set relationship as well that it's 22.4 liters in 1 mole. So in terms of our relationship, it's nice to have a nice visual representation, so I encourage you to use something similar with your students if you're teaching your chemistry concepts. Well, we can do our relationship here. So 1 mole is equal to 22.4 liters. Again, just a reminder, that's for gases at STP only. We can relate a mole to particles, and we use our Avogadro's number, 6.022 times 10 to the 23rd particles. That's how many particles are in 1 mole of a substance. And then in terms of mass, we simply use the molar mass, which we get from the periodic table. Now, if it's an element, we just use directly what we get from the periodic table. If it's a compound, we have to add up the masses of everything that's in that compound to get the molar mass for the compound. Now we can do some conversions, and this is what we went over in our last session. You can always access previous sessions. There's the recordings available on the mNET website, so do make sure you check those out if you need to go back and see previous sessions, or if you're preparing, for example, for an upcoming exam, make sure that you go and check out the sessions that you are struggling with. So let's look at a practice problem here. It says how many grams are in 4.53 times 10 to the 25th molecules of water. So think about our conversion here. We're trying to start with molecules, which is a type of particle, and we are converting to grams, which is our mass. And I did go ahead and give you the molar mass here. So again, we couldn't get the periodic table open, but at least we have our masses available. So let's think through what we need to be doing in terms of our conversion. We are going to be going from particles to mass. And we don't have a direct conversion here at the bottom, so what we're going to have to do is we're going to start with particles. Our first fraction will convert us to moles, and then we'll use a second fraction to convert to mass. We're going to be using fraction conversion factors as we work through this, and it's very important that your students set problems up this way, because in terms of then moving on to stoichiometry, they're going to need to set up those conversion factors. So even when you start chemistry to begin with and you do basic conversions like metric system conversions and English to metric conversions, just to get them practicing with their conversion skills, encourage them to set up those conversion fractions, because they'll continue to use those skills as we keep working through our chemistry. So again, we're going to go from particles to moles to mass. So we'll have 2 fractions. We start by writing down our given, the 4.53 times 10 to the 25th molecules of H2O. The first thing we're going to do is convert to moles, and we'll use our 6.02 times 10 to the 23rd. Now, in setting up these fractions, we always want to make sure that we give the unit and the substance. So this is how many molecules, which are a type of particle, are in 1 mole. And notice why we set this up the way we did. It allows our molecules to cancel out. We always make sure that everything cancels out as we are setting it up. Then we're going to go ahead and convert to grams. Notice this fraction 1 mole, so that is the molar mass. Notice the moles are on the bottom, so that they will cancel with the moles here. So think about canceling out your units. Molecules and molecules cancel, moles and moles cancel, and we're just left with grams of water. Math-wise, we're multiplying across the top, dividing by the bottom, and I would encourage you when you do this in your calculator, put these numbers, the scientific notation, put them in parentheses. That will help to avoid any problems with order of operations on the calculator. But sometimes you might get a funky answer. Again, if you use parentheses, that should help. Start to think through and start to guesstimate the type of answer you should get. So if we're taking a number that's 10 to the 25th and a number that's 10 to the 23rd, those are going to even out so that we end up with a 10 to the 2nd in the numerator. So start to think about your answers. If you end up with a 10 to the 48th, we know we've done something wrong. So we punch that in, we end up with an answer of 1360 grams of H2O. In terms of sig figs, if you're working with your students in sig figs, for conversions, however many you start with is how many you end with. So we started with 3 sig figs, and we end with 3 sig figs. So we did some of these in our last session, so hopefully we're pretty much so up to speed on our mole conversion. So now it's time for you all to try some. Again, hopefully you have your pen and pencil and also a calculator handy, because you'll need those if you need to. Otherwise, you can try to do some guesstimating as you're working through and trying to estimate an answer. But let's look at our first practice poll question. I'll give you guys a little bit of time to work through the calculation. I'm going to go ahead and open our poll question, so it's open when you are ready to vote. But let's talk through a little bit what we're going to need to do. So before you start punching away there, we're asked how many liters at STP are contained in 4 times 10 to the 24th molecules of H2. So we're going from molecules to liters. So let's look at our mole roadmap. We're starting with a particle, and we're trying to go to volume. So think about your fractions. We're going to have 2 fractions, particles to moles, and then to volume. So start thinking about that. I'm going to go ahead and switch back to our actual problem page. You might want to jot those numbers down. So here's our actual problem. There's the molecules you're starting with. So I'm going to give you about a minute to try to punch that in and work through. All right, so we've got lots of voting going on, which is great. Hopefully we've been working through and doing our calculations there. So we've got a majority going for one answer choice, going for C. So let's see if we are correct. So let's think about our math here and what we need to do. We're going to take our given information, which is the 4 times 10 to the 24th molecules of H2. Well, then first thing we're going to do is convert that to moles. So using our 1 mole over 6.02 times 10 to the 23rd molecules, we see that our molecules cancel out. And then we'll go ahead and convert to liters using that 22.4. Multiply across the top, divide by the bottom. A 10 to the 24th divided by a 10 to the 23rd should be 10 to the 1st. So we want to make sure we don't get anything like, again, 10 to the 47th or something. And then we work through our math. We get 149 liters. And if we look at our answer choices, that is, in fact, answer choice C. So great job in terms of working through that calculation. Awesome job. We're going to look at another problem. So let's start to look at this one. How many molecules are contained in 73 grams of H2SO4? So start thinking through what you might need to do. You will have the masses, and we'll come back to this, but let's think about what we're doing in terms of our actual calculations. So you're going to start with a mass, and we're asked to go to particles. Molecules are a type of particle. So again, I think we're going to do 2 steps. We're going to convert from mass to moles, and then moles to particles. Think about your number here, the 6.02 times 10 to the 23rd, and I give you the molar masses. So let's go back to the actual problem. Again, I'll give you about a minute to work through that, and then we'll compare our answer for that one. I feel like we need some Jeopardy music here, so we have a countdown, or I need a little countdown timer for us. We got some great voting going on. I think for time purposes, let's go ahead and stop our voting where we are. You're still calculating, go ahead and continue punching away what you are, but let's think about our math setup here. So again, we're going to take our given, which is the 73 grams. First thing we need to do is convert that to moles, so hopefully we added up the molar mass of H2SO4, so the mass of 2 hydrogens plus 1 sulfur plus 4 oxygens. That gives us a molar mass of 98.086 grams. That's how many grams are in 1 mole. We'll then go ahead and convert from moles to molecules using our 6.02. Be careful with your math, multiplying across the top, dividing by the bottom. We should be looking for a pretty big number, so when you punch that in the calculator, particularly if you're using a TI calculator, it'll say the number and then it'll say E24 or something along those lines. The E means the times 10 to the whatever exponent. So make sure you're reading that carefully on your screen. When we punch that in, we get 4.48 times 10 to the 23rd. And again, that way that might have been written on your screen was 4.48 E23. That means times 10 to the 23rd. If you look back at our answer choices, that is answer choice D, which we had, I guess we could call that a majority. 2 out of 4 that voted went ahead and selected answer choice D. So great job in terms of working through those practice problems related to moles. The next thing that we're going to go ahead and talk about, and I just gave this as a note for myself, is we're going to talk about pre-assessment. So if we've noticed our strategies for the month, we have a monthly strategy in our science sessions, or a monthly kind of general classroom strategy. And so our strategy for this month in science is pre-assessment strategies. So what we're going to look at is talking a little bit more information about pre-assessments in general. Now, how many of you, let's do a yes or no, how many of you use pre-assessments in your classroom? So just type in the chat box, yes or no. Do you use pre-assessments in your classroom? Fantastic. Well, I bet you guys are all pretty much so experts, so hopefully I can give you a little bit of extra information here this evening or give you some ideas you maybe haven't thought about before. But just making sure to review and understanding kind of what a pre-assessment is. It's a way to determine what students know about a topic before it's being taught. So we're just trying to get some background information and figuring out what students know. It kind of helps to guide us so that we don't teach them something that they already know. So what should pre-assessments be used to do in order to give us information for working in our classroom? They should be used to make instructional decisions about student strengths and needs, determine flexible grouping patterns. So sometimes we like our students to do group work, and by seeing how they do in the pre-assessment, then we can group them into the appropriate groups. And then determine which students are ready for advanced instruction. As I mentioned before, we're doing a lot with individualized learning these days. So making sure that we are challenging our students, and those who are ready for something advanced, we want to go ahead and give them those advanced assignments. So hopefully, again, we've used our pre-assessments for some of these different types of things in terms of planning in our classroom. It also just gives us a good general knowledge about student information and student learning, what they've learned so far. We know a big issue that we see in our science courses is that a lot of times students end up with misconceptions, and then those misconceptions kind of stick with them. And so we can identify some of those misconceptions by using our pre-assessments. Whoops. So first of all, some general strategies, and I've got a little bit of out of order here on my PowerPoint file. I apologize. So first of all, we need to make sure we decide on how we're going to use the pre-assessment. So we're going to do a pre-assessment at the start of a unit, which is a great data tool in terms of getting a baseline, seeing what students know at the beginning of a unit, and then doing similar questions on the post-assessment or that final culminating test to see if students have learned the information. So we might do a unit pre-assessment. We might just do a general course pre-assessment, so students come in at the beginning of a course, seeing what they know from previous science courses. Or we might also do just kind of a daily pre-assessment. And daily pre-assessments might be something that's very short, just a one question little assessment to figure out what students know for what you're going to be learning in that lesson on a particular day. So lots of different ways that we can incorporate our pre-assessments. Key thing is to keep it short. We do, especially if we're using it on a daily pre-assessment, so we want to keep it to a minimum so it's not taking up a bunch of our class time. But a lot of times this can be, for example, we call it a bell ringer sometimes if we're using it on a daily method, just to kind of figure out what students know, and we can kind of get a quick idea of how the day is going to progress. Also encourage you to mix it up. So sometimes we get stuck in a rut with our teaching, and I know it's hard when we're new teachers and we're doing so many different things, and we can just kind of get in a rut where we just kind of do the same sort of thing. We always give a multiple choice quiz, or we do things the same way. I would encourage you to just try to mix it up, even if it's just a little bit of mixing up, just trying to keep things a little bit different in the classroom. It will help to keep your students more engaged, keeps them on their toes more. It'll make things a little bit better for you as well. You're not going to be stuck in that mundane situation where you're always doing the same thing. And then also make sure that we are using the data. So make sure when we're gathering that data that we actually use it. If you're taking the time to gather it and get some information, make sure you apply it in the classroom. So if we are going to set up different groups and do differentiated instruction, make sure that we're using that data to do so. So do follow through with it. Now in terms of pre-assessments, we do have different types. Scenario where we're asking specific content-based questions. We're really trying to figure out what do the students know from their previous courses. And again, this might be like our typical paper and pencil quiz. Just to throw out a couple of science examples to help you think about how this would be relevant in the science classroom. If you asked your students, for example, in a biology class to draw and label a food chain, including plants and animals, that might be a quick pre-assessment tool if you're getting ready to work with food chains. Or ecosystems overall, and trying to figure out if students have an understanding of what a food chain is. You could ask them to draw it, and then you get some kind of background information. Or even if you ask them a simple definition, again, this could be a start to the classes one day. If you're going to start into stoichiometry for chemistry, maybe you ask the students to just jot down on a piece of paper what does the word stoichiometry mean? And see if they have any idea. You can kind of get a background information to see if they know something about stoichiometry to begin with. Or maybe you're using this day. So it's another way we can use our pre-assessments to see if they retain that knowledge from a previous lesson. We also have some of our pre-assessments that are more skills-based. So this focuses on students practicing an actual skill as opposed to just your rote pen and paper quiz, for example. They might still have paper and pencil involved, and they might still be content-based, but we're typically trying to have students do a little bit more or testing out their skills. So a couple of examples to get you thinking about what these might be. If you ask students, for example, to create a scatter plot with the data listed in a given table, so you're trying to see what their graphing skills are like. We know that students have been learning graphing for a long time in their math and science classes, but when they come to us, they might not have the best graphing skills. So this could be a quick way to assess, do they have the skills they need to successfully create the graphs that they need to create in our class. Or asking them to draw pictures. So for example, if we're going to talk about a bonding concept in chemistry, asking students to draw a picture to demonstrate covalent bonding. Again, you could do this before they learn about covalent bonding, or you could do it the day after to see if they retain the knowledge from the previous day. We also have different types of pre-assessments that are more active, so I encourage you, like I said, to mix it up, get students up and moving in the classroom. So different examples of this would be again, we're looking at having students physically moving around. One example would be 4 corners. So if you set up your room, you put the letter A in one corner, the letter B in another, the letter C in another, and the letter D in the 4th corner. You're doing basically a regular quiz, but instead of having students write it on paper and pen with paper and pencil, you're actually having them get up and move around the room, which can definitely help with students if they're getting a little tired. You could do a quick 4-corner assessment just to see how things are going. So again, you're just asking a multiple choice question, and they go to the appropriate corner. Graffiti wall is another idea. Maybe you have a big piece of paper up on the wall and you have students draw pictures related to the topics that you're talking about. So it allows students that like to express their creative side or trying to get some ideas of different information that they know about, just because it's a different way to express themselves and having students get up and physically move around. Yes, no cards. You can have students just have a card that says yes and a card that says no. And so again, it's kind of a general question type thing where the teacher is asking the questions, but instead of students just doing it on paper, they can actually hold up the cards. And it might be a quicker way for you to assess, just quickly scanning around the room and seeing how students are doing, whether they understand the information. So it just can be a quick assessment tool to figure out if they're understanding what's going on. So just a little bit of information there on pre-assessments. Again, I'm so glad to see that so many of you use pre-assessments in your classrooms. Hopefully we gave you a couple of additional ideas there to think about as you're starting to use more and more pre-assessments and making sure that we're using them to their full potential. So again, I'm so glad to see that you guys are using pre-assessments already. What we're going to do now is get back into our science, and we're going to talk about stoichiometry. So we've talked about reactions, we talked about mole conversions, and we're going to put those two things together and talk about what we call stoichiometry in chemistry. Now, stoichiometry, it's kind of a funky sounding word. It's just a way to relate amounts of different substances in a chemical reaction. So let's say we have our chemical reaction, we have reactants and products. We can relate